Okay. So a couple things that's going to be happening this week and next week. Remember, tomorrow and Thursday are going to be those late start days. You don't have to come in. Class actually starts at 1:35, so the first bell will ring at 1:30. I've got the schedule up here. I'm not going to see you guys tomorrow, but I will see you, Wednesday, and then Thursday will be a 30-minute class. Tomorrow's 1 through 4. Thursday is going to be the 5 through 8. But the homework you picked up today will be due on Wednesday. On Thursday when you come in, because we only have 30 minutes, I've got an exit ticket over the average rate of change that I'll go ahead and have you take a look at. That should be pretty easy to finish up in the time we have allotted. Yes?
So, I'm kind of asking for clarification. So, the average rate of change is basically you get like 2 points on a curve. There's find like essentially like the slope of
Yes.
the point.
hmm Yeah, that's why we have to call it average, because it's not consistent as you follow along the curve.
The average of like
Now, if we want to know the average at a specific location, instantaneous rate of change, that's the derivative. Yes. Okay. And that is, actually the lesson that we're currently working on right now. So here we're still working with the formula. I mean, it was pretty easy for a lot of folks on Friday to pick up the power rule. You know how you pull the power to the front, multiply by the coefficient, subtract 1 in the power. So that's what the next lesson is all about. So until then, we still want to go ahead and use the difference quotient. And that's what a quiz on Friday is going to cover. This material right here, the difference quotient. Okay. And then next week, is going to be a short week because we don't come on Friday the 19th. That's going to be Good Friday. But right before that, on the 18th, that's when we're going to have our first exam of the 6 weeks. Because really, if you're thinking big picture, including this week, we got 7 weeks until the end of school. Okay, so it's going to go really fast. We have basically less than 7 weeks for the seniors who are going to graduate. And we are exactly 5 weeks today away from taking our first paper exam. Okay, so we should be able to pretty much wrap up our introduction to calculus using this week, maybe a little bit of next week, and then from that point on, we're going to get into reviews and see what happens. Okay, all right, so let's see here. We had finished up with B. Let's go ahead and kind of review what we were talking about on Friday. Okay, now we've been looking at this formula right here, f of x plus h minus f of x, all divided by h. Now this is what we call the difference quotient. This is going to help me determine the derivative, but it's still in terms of h. This is what the homework's going to be over. This is what the quiz on Friday is going to be over. Now if I want to know the actual derivative so that I can find the instantaneous rate of change, I take the limit as h approaches 0. Okay. So why don't we get right back to it? We did B, but I don't believe we did A. Is that right?
no.
Okay. So x is going to be placed in the function 2x cubed, and we want to evaluate it at x equals 1. Okay, so at x equals 1, we want to know the slope of the tangent line right there. Okay. So we want this, f of x plus h minus f of x all over h. We want to apply this formula to this function right here. So first, we want f of x, which is going to give me what? That's just 2x cubed. Yeah. F of x is always the original function. Now for f of x plus h, this is where we're going to use substitution. So everywhere I have x, I'm just going to replace it with that binomial. So 2x cubed is 2 times x plus h cubed. Okay, and now we need to go ahead and expand that. Do we want to go ahead and run through the? Didn't we do a cubed on Friday or something last week? Is it okay if I just write it out, or do you want to run through the whole process? Just write it out? Okay. So I'm going to go ahead and leave the 2 here for the time being. So we should end up with 1x cubed plus 3x squared h plus 3xh squared plus h cubed. That's if I want to go ahead and take x plus h and cube it. Okay. All right. I've been working with in pre-calculus the binomial theorem and Pascal's triangle, so that's much more fresh in my mind. Has anybody heard of that before? Okay, a few things. Okay, maybe if we have time, I'll go ahead and show it to you. It's really cool. But is everybody okay? Okay, now we just distribute the 2. So it looks like f of x plus h will equal 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. Okay. Now it's just direct substitution. Okay. For this first numerator, f of x plus h, I'm going to replace it with this expression I just got when I plugged x plus h into my function. So I'm going to come down here where I have a little more room. So my first set of numerators is going to be the 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. Okay. Now we're going to subtract, there's the minus right there, f of x. Okay, but f of x, remember, was just 2x cubed. Now, because it's just a monomial, I don't have to worry about parentheses. I'm just going to put minus 2x cubed. Okay. And this is all over what? All over h. Now, we also talked the other day, you can go ahead and put the limit as h approaches 0 in front of it and kind of carry it through, or you can simplify and then go ahead and put the limit in front, whatever you prefer to do. But is there anything that's going to drop out? There we go. So 2x cubed minus 2x cubed. At least one pair of terms should always drop out. So let's see. What is 6x squared h over h? So that's 6x squared plus 6xh plus 2h squared. Okay, now normally the very first part of the lesson that we were on last week, we would go ahead and stop there. Remember, we did it in a progression. So now that we have this expression, I'm going to take the limit as h approaches 0. So as we talked about last week, basically any term that still has an h does what? Yeah, just disappears. It just goes away. 0, there's 0. So the derivative is actually 6x squared. And if you go back, if you take a look at that power rule, again, I still want you to do the homework using the difference quotient until we talk about the power rule, but 3 times 2 does give me the 6, and then subtract 1 from the power. See, that's exactly what we got. Okay. Now, there's something I still need to do on the problem. There we go. So see, this right here, this derivative will allow me to find the slope of a tangent line anywhere on the function that I want. Okay. So if I want to know what the slope of the function is when x equals 1, I'm just going to plug it in there. So 6 times 1 squared. So I have a slope of 6. Okay. Does anybody want me to graph that on the calculator and then kind of show you that that should be a slope of 6? We're good? Okay. Hey, Emily. Mm-hmm. This one's just the notation. This one is, it's just the way it's written. We're still saying that the function f of x is 2x cubed. Yeah, it's just a different way of writing it. Okay. But I did go ahead, that quiz that we got on Friday, I went ahead and made sure to write the instructions out similar to what we have here. When it says find the gradient of the secant line, remember that's when we want our answers in what variable? We want left in h, yeah. So you won't take the limit as h approaches 0. But then if you're asked to find the derivative or the instantaneous rate of change, that's when we go ahead and take the limit as h approaches 0. Okay. So I made sure to go ahead and put the same instructions in there so you would know which one to go ahead and use. Okay, we got one last problem, and then we are done with these notes. Okay, an object is dropped from a building. The distance d meters that the object has fallen, t seconds after it's released, is given by the formula d equals 4.9 t squared, okay, where t is between 0 and 3. Okay, so A, find the distance fallen during the first second. Okay. B, find the distance fallen between t equals 1 and t equals h plus 1 seconds, and then find the speed of the object 1 second after it's released. Well, hey, did I make a mistake? It's not at the end of your notes?
It's number 2 on the homework.
It is?
Yeah. One behind.
Wait a minute, because I got the notes right here. And it's
It's different.
Ours is a particle moving along straight line.
yeah, okay. Whoa. Maybe I'm looking at the wrong. Oh! That's why the work I did there for part A, I just immediately thought that was a problem we already did. That's why I skipped to it. Oh, okay. See, if nobody had said anything, we would have done the problem on the homework. Dang. Okay, so now we're on the right problem. This is the last part of the notes. There we go. Okay. There we go. Okay, so let's take a look at this one. A particle moving along a straight line has its position at time t seconds, governed by the equation P of t equals t minus 0.2 t squared, where t is greater than or equal to 0, where P of t is its position in meters from a fixed point O. A, find the particle's velocity after it's been in motion for 1 second. Actually, when you see instructions like this, we talked the other week, there's a lot of different applications for derivatives. One of the better applications is that the first derivative will always give you speed or velocity of an object. I think we mentioned this last time, right? Okay. Does anybody remember what the second derivative gives you? Acceleration. There we go. So the first derivative can provide you speed or velocity, while the second can provide you acceleration. So if we want to know the particle's velocity at a particular time, well, then we need to go ahead and find the derivative of that. Okay, so because it's t, I'll go ahead and kind of change the formula. F of x plus h becomes t plus h minus f of t. Or do you want me to go ahead and do it with x? I mean, does it matter? You want to do x? Okay. Okay. There we go. So x and x all over h. Okay. And also, I mean, I guess I could change it because this is function p. Do you want me to go ahead and change those to p's, or does it matter? No, it's just the name of the function. So if you want to do p of x plus h minus p of x, man. Okay. So I'm just going to go ahead and stick with the formula. So f of x is just the original function, t minus 0.2 t squared, or x minus 0.2 x squared. Okay. Now for f of x plus h, every variable is going to be replaced with that binomial. So f of x plus h equals x, so that would be x plus h, minus 0.2x squared, 0.2 x plus h squared. Okay, and then now we just have to expand that, combine my like terms, get all that good stuff done. Okay, would you like to try and expand it on your own, or you still want to go ahead and do it together? You want to do it together? Okay. Let's do it. So again, would anybody like to see me FOIL those, or can we just expand it to the trinomial? Just, okay. So I'm going to go ahead and drop the parentheses on this one. X plus h. We're not going to go ahead and distribute the 0.2 yet. So x plus h squared would give me what? X squared plus 2xh plus h squared. Okay. And remember, what was also another way I talked to you guys about doing that? Square the left, square the right, double the middle. And then what was it we said? The answer's in sight? Yeah, there you go. Okay. All right, now I'm going to distribute. So equals x plus h. Okay, so that would be minus 0.2x squared. Minus what? 0.4 xh, right? And then what? Minus 0.2 h squared. Okay. And are there any like terms that I can pull together? Okay, what? No, so nothing right now. Okay. So just like we've done before, this whole expression is the original function with the variables substituted x plus h. That's the first part of my formula right here. So I'm going to say x plus h minus 0.2 x squared minus 0.4 xh minus 0.2 h squared. Now I'm going to subtract, okay, Okay. I do have a binomial expression. Is it okay if I just, in my head, distribute the negative, or does anybody want me to actually plug in the parentheses? Okay. So this would be minus x plus 0.2 x squared. If I were to subtract the binomial, is everybody okay with that? Okay. And then this whole numerator is over h. Okay. Now what can cancel? Okay. So let's see. We have 0.2x squared. There's a negative. There's a positive. We also have x minus x. Okay. So it looks like I have two terms left, which would give me what? Negative 0.4x, because those h's are going to cancel, minus 0.2h. Okay, so now what I'm going to go ahead and do is take the limit as h approaches 0. Okay, so remember the expression with h would be the gradient of the secant line. The actual derivative to find the instantaneous rate of change, I would take the limit, and this guy is going to disappear. So it looks like my derivative is what? Oh, I forgot one. I'm sorry. Did anybody see what I did? I forgot about this h over here. So h divided by h, that would actually be a 1. I'm sorry, so I forgot an h. Is everybody okay with that? So it actually should be 1 minus 0.4x. That should be my derivative. You heard somebody knock, right? Someone walking down the hallway, but nobody was there. Okay. All right, is everybody okay? I forgot about this h right here. I'm sorry. So h divided by h is where that 1 came from. So only one term disappears. Okay. Is everybody okay with that? Okay. Now, part A says find the particle's velocity after it's been in motion for 1 second. Okay. Well, that's easy enough. Okay. When t is equal, well, in this case, x. When x is equal to 1, 1 minus 0.4 times 1. So what would that be? 0.6. Okay. And what are we talking about here? Meters per second. There we go. Meters per second. And actually, one thing I've noticed, I don't really think I've touched on it very much this year. We haven't had a lot of opportunity for that. But you know how here in America we always say meters per second, we use like the little division symbol? What they like to do in IB is they'll keep everything mainstreamed, so meters times second to the negative 1. They like to keep it with a negative power. So in case you were to see that, you know, don't let that throw you off. Okay. So there we go. And then B, I think it just wants a variable. Find the particle's velocity at time t equals a. Okay, so if x is equal to some time a, well then it would just be 1 minus 0.4 a. I mean, without being given a specific value, that is as far as we can go. Samir, do you have a question? Oh, okay. Okay, questions. How we doing? Okay. All right, and now I believe, there we go. Then now you can do that problem number 2. Yeah, very similar to what we did there. Awesome. Yes, ma'am. How did you find what? What I solved for C?
No, would you solve for T?
Oh, solve for T. Oh, no, like A says find the distance fallen during the first second.
Right.
So here, are they even asking you to do anything with the derivative? No, see, this one here, the formula is the distance equals 4.9 times your second squared, because objects fall at 4.9, what? Meters per second, right? Per second squared. So In this B right here, find the distance falling between t equals 1 and t equals h plus 1 second. So A and B are not dealing with the derivative, but how do I know that C is the first time it wants me to find the derivative? What's the key word? Find the speed. Remember, the first derivative is speed. Okay. So like in A, find the distance fallen during the first second. So the distance would just be 4.9 times 1 squared. So it should fall 4.9 meters. That makes sense? Okay. All right. Good, good, good. Well, I think that one only has, what, 5 questions on it? Definitely not a whole lot. I mean, I'm sure you guys were looking forward to doing something tomorrow morning rather than, sleeping in. Oh, sí. Hola.
They speak Spanish.
Oh, do they? ¿Dónde es la biblioteca? I don't know. That's a library, right? What's that?
Where is that? What's that from? That's like a quote from a movie.
Oh, yeah, I mean, that's... The movie I'm thinking of is Encino Man. But I don't know if you guys are old enough to know what that movie is. It's one of Brendan Fraser's first movies. Do we know who Brendan Fraser is?
The Mummy Killer.
He was in The Mummy in the late 90s.
Yeah.
Okay. With Arnold Vosloo and Rachel Weisz. He was also in Journey to the Center of the Earth. He currently plays Robot Man on Doom Patrol on DC Universe. Okay. Well, good. There you go. Okay, so let's do this. I've been wanting to get to some of these because I'm ready to start reviewing, and I know you guys are the same way. How many people have had the opportunity to take a look at this review? At least number 1. Oh, uh-oh. Okay. Would you like to go ahead and do one of these together, or you just want to take the rest of the time to look over your homework? Let's go ahead and at least do number 1. Okay, I like that. There we go. Now, number 1, this is on that review, and I believe it's very possible there's going to be extra copies over here. Hopefully. Yes, there are extra copies over here if anybody needs one. Okay. All right. Okay. Mr. Jones decided to increase the amount of money he spends on food by D Great Britain pounds every year. In the first year, he spends a amount of GBP. In the 8th year, he spends twice as much as he did in the 4th year. In the 20th year, he spends 4,000 GBP. I can't say that very quickly for some reason. Find the value of D. Well, do some of these variables look familiar? What concept is this? This is sequences. There you go. In fact, is this arithmetic or geometric? This is arithmetic. There we go. All we're wanting to do is increase the amount of money he spends a certain amount every year. He's already spending a certain amount each year. He's just wanting to raise it. Okay. So we had several formulas that went along with this. If we want to figure out the nth term of an arithmetic sequence, we have a sub n. Or did we use a or u in here? I can't remember. Did we use u? Okay. So u sub n is equal to, does anybody remember the formula I'm referring to? The first term, u sub 1.
Plus u sub n minus 1.
You're very close.
N minus 1.
Just n minus 1 times what? D. Remember, that was the common difference. When you had a geometric sequence, we used R, which was the common ratio. So it's been a while. I want to say this was before Christmas the last time we really talked about this one. Does that look familiar? Okay. And that's the thing. I mean, everything that we've talked about the entire year, that is fair game for these paper exams. Okay. So guaranteed, at least everything's going to show up once. Okay. Well, I can walk you through how I did it. I can give you a little bit of time and then give you the answer. Maybe we can talk about it on Wednesday. What would you guys like to do? What do you think is going to be most beneficial for you? Would you like the opportunity to try it on your own and then we can talk about it? Or do you think it's going to be better if I just stand up here and show you what I did? Because remember, is my way the only way? Absolutely not. There's going to be a lot of ways to approach these. What would you guys like? Talk amongst yourselves.
Is Wednesday good for me? I wasn't paying attention. I was focusing on my math, bro.
That's what we found.
What he's talking about.
Yeah.
Really focused.
Well, that's okay. We're all algebros in here.
Because I was
Okay. So you don't want the opportunity to try it on your own. You want me to show you what I did.
yes, yeah.
Okay. Or I can at least do one better. I can go ahead and tell you what the answer is and then how I did it on Wednesday. I mean, I got no problem. I'll do it right now. Or at least maybe I can get you started.
Yeah.
Okay.
So what exact? So my only question is like, what's the common difference?
The common difference is what you're going to add over and over again. So for example, if I had a simple sequence like 8, 11, 14, ... What am I adding over and over to get to the next term? 3. So here, that's the common difference. So the next term would be 17, then 20, and then so on.
Well, I mean, what was the common difference in like the scope of the problem? Because I know what the common difference is.
Oh, the value of D, he's already placing so much money aside every year. The question is ultimately asking, he's wanting to increase the amount of money that he's putting aside every year. So based on these little clues, how much more is he going to increase what he's already putting aside? Just the value of D is what we're looking for. Okay. D will be an actual value, yes, in British pounds.
So it seems like for year one, did he only spend 1 British pound?
Well, he spent an A number of British pounds. Okay, so we're using the variable A. Okay, so I'm going to go ahead and say U sub 1 is equal to A. Then it tells me in the 8th year, he spends twice as much as the 4th year. Okay, so I would go ahead and start with the 4th year. So I'd say U sub 4. Now, do you remember anything about that subscript? That little subscript is what variable? That is n, okay? So I'm going to apply what I know to this idea here. So I'm going to write this back up here. So U sub n was, I keep wanting to put A, U sub 1 plus n minus 1 times D, okay? Well, in the 4th year, we already know that the first value was A, okay? Plus, well, if I'm trying to go for the 4th year, what's n? Okay, it's 4. So I'm going to go ahead and say 4 minus 1 times D. So if I go ahead and simplify that, A plus 3D. Does that make sense what I've done? Okay. Now I'm going to go ahead and do the same thing for the 8th year. So we start with the first term A plus, but what's the value of n this time? 8. So this would be 8 minus 1 times D. So that would be A plus 7D. All right. And now I'm going to go ahead and go one more. Okay. In the 20th year, he spends 4,000. So I'm going to go ahead and say U sub 20 is equal to 4,000 British pounds. So this is all the information I know so far, right? Okay. Now, in order to solve this, it goes ahead and tells me something comparing the 4th and the 8th year. The 8th year, he spends twice as much as the 4th year. So what I can do is use that sentence to help me create an equation. So I'm going to go ahead and set the 4th year equal to the 8th year. So 3 plus, sorry, A plus 3D is equal to A plus 7D. The 4th year equals the 8th year, but they're not quite equal just yet. There you go. See, in order to make this equal, whatever he spent in the 8th year, it was twice as much as the 4th year, right? So I could either take the 4th year and double it so that now they're equal, or what could I do to the 8th year? I could take half of it. Either way, I should still end up with the correct answer. Okay. Now, would you like me to continue? Or do you think you can take it from there? Spencer, you have the answer? Okay. Sure. It is 200. Here we go. Okay, so let's see how we got that 200. So 2a plus 6d is equal to a plus 7d. Okay, well, what are you going to notice when I go ahead and subtract these? There you go. If I subtract the a over, if I subtract that d, I know that a is equal to d. Yes, ma'am.
In this case, wouldn't we be able to divide the 4,000 by 20 and then just multiply by the year that we want it to be? Because that gave me the 200.
And then multiply it by the year we want it to be?
That, oh wait, we're not looking. But doesn't that already tell us that the A is going to be 200?
So you took the 4,000 and did what?
Divided it by 20.
Divided it by 20?
We get you 200.
It does give me 200. I don't know if that's a fluke or if that is
I
just...
think it only works
a shortcut.
in this case because A equals D. But if D did not equal A, then that wouldn't have gotten
No,
the
yeah.
right answer.
Yeah, I would agree with them. Okay. I think the fact that, yeah, the 4,000 divided by the 20 gives me the 200 on this case is just because of that.
But one 4,000 dividing, but if you divided 4,000 by 20, wouldn't that give you A though? Because that has a common difference. So it'd give you A.
Yeah, but think about the grand scheme of the problem. We're wanting to increase the amount that we're putting aside every year by D amount. So, okay. Yeah, some of these, don't get too involved with them. It's real easy to get turned around in this problem. In fact, how many people are already kind of confused? That's okay. That's okay. Now, here's what I'm going to go ahead and do. Okay. We've already used that the first term is A in my calculations. We were able to get to this point here because we used the fourth and the eighth. What's all that's left? Okay.
Oh, wait,
The 20th year.
A per D,
There you go. Now I'm just going to substitute. I'm going to go ahead and say the 20th term is equal to the first. Remember, that's just A. Plus, well, what's N in this case? 20. So 20 minus 1 would be 19. D. But there's two things I'm going to do here. Is everybody okay with how I got that equation?
Yeah.
We already know that A is equal to D. So I'm going to go ahead and replace A with D, and we already know the amount, the term number for 20. So I'm just going to replace this with 4,000. So 4,000 equals 20D. D is equal to 200 British pounds. Okay. That one's easy, right? How many people would have been able to get that right off the bat? Okay, that's why we're going to practice. That's why we practice this. Okay. I'll tell you, number 2 is just a scatter plot problem. Okay. We'll probably remember more about that than we did the sequences. I'll go ahead and tell you number 3 is another sequence problem. Okay, but this one is using Swiss francs, but whatever kind of currency you're using does not matter. It's not applicable to the problem. Just work with those numbers. Okay. All right. So good. So how many people just feel so excited they're going to rush home tonight and do more of that review?
I can stay up all night.
There you go. That's it. Yeah. Okay. Yes. The homework's due Wednesday. Okay, the current homework you just got today is due on Wednesday. Okay. And I'm hoping that early next week, once we finish up with the calculus, we can go ahead and just start focusing on these reviews full time. Okay?